All right, cool. First of all, thank you all for coming out. Got a ton of content to get to, and I'm going to move pretty fast through this stuff. If anyone wants to chat after, I'd be more than happy to. So my name is rbayliss, and I'm here to talk to you about some performance wins that we've gotten recently at Mass.gov. I'm the CTO at Last Call Media, and a while ago, I was invited to join the digital services team to help them kind of get the platform stabilized and make sure that everything is shipshape. I'm here actually with Moshe, who's going to help answer several questions at the end. And Moshe has been with the project for a while?
The whole time.
The whole time, okay. So just to kind of back up and talk for a second about Mass.gov, this is the website of the Commonwealth of Massachusetts. The primary stakeholders are the constituents who visit the website and the state organizations who publish content on the website, and additionally go to the website for aspects of their job. It typically receives around 15 million page views a month, and changes are getting released twice weekly by an entire team of developers. First, I'm going to be talking about the backend performance, and then we're going to switch gears and kind of talk about the front-end performance gains that we were able to make. And we made changes on both ends there that I think are pretty dramatic. So just as far as our mission statement, on the back end, our problem is state employees need to be able to publish content quickly. So as an example of that, like someone from the governor's office needs to go in and publish a press release, and that needs to go live on the website fairly quickly so that they can get it out to the general public. Also in the picture, constituents need fast access to that information that's being published, and they need to not have any disruptions in visiting the site. So everything we do is going to be in service of either stabilization on the one hand or content freshness on the other. And so you can think of these two things as opposing forces that are on opposite ends of the scale. As we allow content editors to publish content with greater freshness, it's going to take away from our stability. And so we need to find a way to balance those two aspects and really allow people to publish content quickly but also have minimal disruption to the site. The traffic profile of Mass.gov is really interesting. I was kind of shocked when I first started looking at the graphs. What we see is that the vast majority of our traffic is 9 to 5 during the business week. So visitors are coming in all day, pretty much from 8 a.m. to 8 p.m. Editors are working during the business day, and then releases are happening after the workday is over, so after 8 p.m. And you can see on this graph those spikes. There's always 5 of them corresponding with the work days. If there are 4, it's because we had a holiday. It's very, very predictable. And then the traffic or the response time during the weekends is very low. And we'll talk about that in a moment. The environment that we're set up with is fairly standard. We have a CDN up front that is serving out the vast majority of page views that come from Mass.gov, and that caches both static assets and dynamic content for a certain amount of time. Behind that, we've got Varnish, and Varnish is going to also hang on to that static and dynamic content. So we've got 2 layers of caching there that are in between the visitor and our actual backend servers. And then below that, of course, we've got the web tier, which is where PHP is running, and we've got a database behind that. It's worth noting, I think, that as we were doing all of this performance work, we had 100% of our caches coming from the database cache. And that's pretty remarkable, just because the prevailing wisdom in the community is that in order to scale, you need Memcache or Redis or something like that. We were able to achieve pretty dramatic results even without those things, although we did add Memcache later. So I'm just going to step through the timeline. September 2017, we had the site launch, and the site was in pilot mode, meaning it was available to people who knew the address. Pilot.mass.gov was up for preview. But on September, I think it was 26th, they switched the DNS from pilot.mass.gov to Mass.gov. So all of a sudden, we saw an increase in traffic, and that corresponded with a small response time bump. And what we're looking at here is a New Relic graph. We're going to see a whole bunch of these. The yellow here is the time spent in the database, and the blue is the time that's spent in PHP. And where that arrow is where the site launch happened. You can see that there's like a modest increase in response time. We went from, say, 400 milliseconds to closer to 600. So handled it pretty well, and that's because most of the traffic is bouncing off the CDN. And just to back up for one moment, the spikes that we saw during the workday really go down over the weekends because so much of the traffic on the weekends is bounced off that same CDN. All right, so we knew we had a content freshness problem. We had the CDN lifetime set to 1 hour, and that was a long time for someone to wait if they were publishing content. So in November, toward the end of November, we started moving things closer to like the freshness side of the scale. We rolled out the purge module, which we use to clear varnish anytime content is updated. So what that means is that editors go from content changes roll out no sooner than an hour to it's going to take less than an hour for your content changes to go out. We're still not clearing the CDN, and the CDN still has an hour lifetime. So it could take up to an hour still. So we got a little boost to freshness, but really we started to see a lot of spiky traffic loads. And you can see in this graph that we have a ton of little spikes, and then also you can see that the response time spiked up to like 2.25 seconds as a result of this work. So we're introducing freshness, but we're starting to destabilize the site a little bit. So as the platform support team, we really looked at that and started to get a bit concerned. In December, we realized that we had a cache tagging problem. And what I mean by that is every page that goes out from a Drupal 8 site ends up getting what are called cache tags attached to them. And cache tags are a way of marking what content is used to generate the page, and a way of saying that, like, okay, when, for example, this early childhood education and care page also depends on the learning page, which you can see up there. When that learning page is updated, we need to clear this page too. So those cache tags in debug mode, like in non-prod settings, end up in an HTTP header that we can see. And we can see that like node 3566 is part of generating this page. So what we realized is that we didn't have all the tags that we needed to, and as a result, authors were updating content and not seeing their changes reflected in the way that they were expecting. So we went through and fixed that by sort of linking up all those cache tags together so that they were propagating to the pages that they should. That did nothing good for our performance, but it really helped get things fresher. In response to what we were starting to see as like a growing stability problem, we had increased the cache lifetime, the Drupal cache lifetime, to 3 hours. And that means that varnish is going to hang on to things for up to 3 hours. As a result of our purge work, any content updates would be pushed up to varnish, meaning that if a page was built and then immediately updated, varnish would instantly be cleared. So that 3 hours only applies to content that doesn't get purged out. We really saw almost no performance improvement as a result of this, and I'll talk about why in a few minutes. So fast forward to early January, we had a backend disruption due to some JavaScript changes that were deployed. When I say disruption, what I actually mean is that disruption doesn't typically affect any of the constituents. Because we have the CDN there, it bounces most of the requests off instantaneously. So when we have a back-end disruption, what that really means is that editors are having problems getting into the system. Typically manifests as like login issues, that kind of thing. So we deployed some changes to a new emergency alerts system that would show a banner at the top of the page if there was an emergency happening in the state. And obviously that stuff needs to go out like ASAP. So in development, we had added a cache busting query parameter to the end of like our JSON API URL to get the emergency alerts. And that worked really well in development. But in production, when we deployed that, what that effectively meant is that we were adding one additional completely uncached request to every person that hit the site. So our takeaways here are that every PR needs to be considered for performance impact, and we need some sort of system to be able to check for this kind of thing in advance. And also that even front-end work can have an impact on the back-end performance time, so really all work needs to be considered from the performance side. So once we fixed that issue, we started really getting down to the nitty-gritty of how to improve the performance. And what we saw was that for every piece of content that was being updated on the site, it would clear effectively every page of the site in Varnish. And so obviously that's bad. And that's why we saw such a huge spike in the response time when the purge work was rolled out. That's also why when we raised the Drupal cache lifetime, it really didn't affect our overall response time. So the culprit here was this node list cache tag. Anytime you have a view on a page, by default, you're going to end up with this cache tag being added to the page. And if, any piece of content that's updated is also going to clear that tag. So really that ends up in that situation where you clear massive portions of your cache anytime a piece of content is updated. We have, I think there are like, 800 editor accounts or something, in that order of magnitude on the site. So there's a lot of content edits happening. So we were really seeing no benefit from Akamai in this case. So what we did was we removed the node list cache tag from pretty much every page of the site, and we replaced it with a system that does what we call relationship clearing. And what that means is that when a given node updates on the site, we iterate through it and look for any relationships that it has. So if it has an entity reference field that points, imagine we have node 1 is the one that's being updated, and it has an entity reference field that points to node 2. So what we would do when node 1 is saved is that we would clear the node 2 cache tag. And that solved our problem of content not flowing out to the node 2 page right away, while still allowing us not to have that super broad cache clear happen every time a piece of content was updated. So we also added tests around this, which is pretty critical. And you can see that we had a massive performance boost from that one. We went from, we were spiking up to like 800 milliseconds, and we went down to 400. So that had a huge impact, and I would recommend for anyone that's interested in improving the back-end performance of their site, check this out. All right, also in January, we found that the meta tags module was generating tokens for the meta tags on a page twice. And the token generation on this site was very heavy. So we patched that issue, and we submitted the patch back to Drupal.org. It subsequently got accepted. But our takeaway here is that contrib modules are not actually immune to performance issues. If no one has used them in a high performance setting, particularly, like there can be some real lingering issues there. In February 2018, we had another back-end disruption, and this one was due to some heavy traffic that was hitting an admin view. Again, the symptoms were effectively editor only. So you can see that our response time all of a sudden just spikes up to like 12 seconds. So that was bad. What happened here was we had a particular admin view that had one feature added to it. It was, I think, node ID search. And the editors really wanted this feature. And as soon as they got it, as soon as that change was rolled out to production, the performance of the view actually didn't change. But what changed was the traffic profile that we were seeing. So all of a sudden, editors were using this view. It was very, helpful to them. But the performance issues that we had on the view already were really exacerbated, and we hit that point of no return where the database just sort of choked up. And you can see that most of this spike is yellow, meaning that a lot of the load was coming from MySQL. So the takeaways here, obviously, watch out for changes in your traffic patterns. Like, this was such a small change, but changed the entire nature of the way people were interacting with the site, editors were interacting with the site. So it took what we already knew was a performance bottleneck and just made it, forced a ton of traffic through it. We hadn't prioritized this issue even though we had spotted it earlier. And so I think another takeaway is just to be proactive about identifying and fixing these issues before they become a big deal. Final takeaway here is, I think a lot of people in the performance world have said this, but in Drupal, full pagers are pretty much the worst. They require taking whatever query the view is running and then executing it again. So if it's a bad, slow query, it'll double the performance impact of it. So we can get away from that and cut that load in half just by switching to a mini pager, which doesn't calculate the number of pages that are in the result set. Small, as an editor, I would probably rather see the full pager, but if it's going to keep the site more stable, sure, it's a small trade-off. In February, we got a free performance win just by upgrading to PHP 7.1. You can see the drop that we had there was pretty significant. We went from 500 milliseconds down to, say, 300. And that was, as far as the scope of things that we changed during this project, that was a relatively easy one. I don't know if Moshe would say the same thing, but.
Yeah, pretty easy.
So nice change. Also in February, we added some customizations to our monitoring system. So we were using New Relic for monitoring, and in New Relic, we were seeing a transaction table of all the different things that were happening on the site that was broken down in a really obtuse way. We went in and we started naming the transactions so that they made more sense. And this just required a little bit of PHP code on the back end. Actually, the same change can be achieved using there's a New Relic RPM module out there that does effectively the same thing. And you can see that now we have transactions broken down by really the buckets that we want them in. So we have a dynamic cache transaction, and that's any web request that came out of the dynamic cache. We have an entity node canonical service details. So service details is the content type. And we can see that that's we're spending a lot of time in there. So this starts to give us the ability to get more granular about what's costing us on the performance side. We can say, okay, service details is a major player in the performance game. Why don't we optimize for that? And that really changed the game in how we started thinking about performance and let us make a lot of tiny victories on individual content types. I'm actually not covering most of those tiny victories here because there were a million of them. The platform support team did an awesome job of sort of just knocking out smaller performance fixes as we went. The other thing that we added to New Relic was categorization of transactions. So we could see now what percentage of our anonymous transactions were coming out of the dynamic page cache, and obviously we want to see that gauge fill right up. And we could see how that was trending over time. So if we had a release that really significantly dropped the dynamic page cache percentage, we would be able to check that out. And then finally, some really cool back-end numbers how many node edits are we seeing, what kinds of content are being edited, that kind of stuff is really useful to gaining insight into how your site is being used. Also in February, this was a very busy month for us, we started looking at our cache tables and figuring out how we could make them more efficient. So we broke down, all the cache bins that we had by the number of reads and writes, and also the size. And we can see here that the biggest cache bins that we had 9 gigs of cache data total. And I think this is pretty typical for a big Drupal 8 site. There is some cache bloat that happens in Drupal 8, and we'll talk about why in a moment. But we can see that our biggest offenders are the dynamic page cache table. So all of that page cache does take space. The entity table, the cache entity table. So, the entities that are loaded from the database end up there, and the render cache bin also is pretty big. So those are things that we kind of knew were issues, but we wanted to make them a little bit more efficient. So we knew we were caching some stuff in there multiple times. And just to take a look at an individual cache item and what the problem is, you can see here that this is a cache ID for a single response that's in the dynamic page cache table. And we have what are called contexts on it. So a context is anything that could change and that the response would change accordingly. So for example, if you change the language that you're accessing the site in, that's going to need to change the page content. So we want to serve out a different page. So when you generate a response, you're able to attach cache context to it. And this all happens automatically in the back end. But the context that you use matter deeply. So like, for example, this item uses these contexts, the language interface one we talked about, the request format, which would be HTML here, the route, so that would be the route name, entity node, mass map page, and then the arguments to the route, the theme that generated it, and also the URL path. Just to give a simple example of why we could end up with multiple pieces of content in the database twice. So we have a very simple cache item that was generated at the URL path, visit Massachusetts State Parks. And imagine that this is the response for node 123. So it's visited on this URL, and it's generated once. It's using the URL.path context, so it's going to be specific to the URL that it's visited on. We know in Drupal that you can also visit that same content on node 123 if that's its ID. And so when that was happening, we were ending up with a duplicate item in the cache, same exact content, except that it had a different URL path context. So our solution there was to remove that URL path context and make sure that we were only generating each item once. So yeah, I mean, the idea here is that you want to care about less things in order to generate your page, and that does take some sort of careful dancing with what you're doing in code. So the really problematic contexts that we found here were URL.path, so we kind of talked about that one. The query args of the URL, so if you have like a pager on a page, you need to care about the page query parameter. So there's a way to add the context for that. That's good. You want that. You want the response to change based on the page that you're viewing. But if you're doing URL query arg star, that means that you're changing for every URL query that comes in. So if you have like Google Analytics and you're tracking UTM parameters and those change, you're going to generate a new response for that, save it into your cache, and waste space. Yeah, just as a rule of thumb, you want to try and look at all your global elements and hang on to those in the broadest terms possible. So here's a concrete example. We had a feedback form that's at the bottom of each page. This thing takes a node ID parameter, and that's the only thing that's going to change when it's generated from page to page. We were able to use what's called a lazy builder to inject that node ID after it was already cached. And we were able to generate this thing once and then cache it everywhere and just inject the node ID in right as it was used. So really, we did a lot of work to kind of increase the efficiency of the cache. The other thing I just want to point out here is we did a long, hard look at the difference between the dynamic page cache and the static page cache. And what we found, so these columns are, like this is using none of the Drupal page caching. And for these two pages, our average response time was 477 milliseconds. When we flip on the dynamic page cache, we end up with 161 millisecond response. And then the static page cache, we end up with a 48 millisecond response. So that static page cache response is very fast, but it's going to depend on every aspect of the URL. So again, we're looking at query parameters. We're looking at all the aspects that are going into generating a URL for a page. And it becomes less efficient. The other thing to note is that the static page cache module does effectively what Varnish and the CDN are doing for a given URL. If you have already seen that exact URL, spit the response back immediately. So we were able to get a lot of mileage out of just using the dynamic page cache module, which is much more efficient if you're using our cache context correctly, and also offers a not a bad performance boost over no Drupal cache backend. Also in February, we started we started deploying to a CD environment. This is a special environment that we had every night, and we started crawling pages to check for errors. What we realized pretty quickly is that we were getting a nice snapshot of the performance every night. And so you can see that we have a spike every night, and if that spike starts to go down, we know that something changed in the code that was impacting our performance. So this is a really nice isolated snapshot away from production traffic that'll be changing. This is the same thing every night, and it gives us a very clear picture of what's about to go out to production, how it's performing, and also historically where our gains or losses were. In February, we actually, as a result of this work, we were able to drop the CDN lifetime from 60 minutes to 30 minutes. And so what we did is we moved back toward that freshness side. So all of a sudden, our authors were seeing changes in no more than 30 minutes rather than an hour. Really big win there. The other thing is, as a result of all those performance improvements that we did, you can see that the entire graph just slides off to the right here. So the overall effect that we had on backend performance is we cut the time to publish right in half, from an hour down to half an hour. We also cut the average response time seen by a user of the site by over 50%. And that actually doesn't matter too much on the scale of an individual user. These times are very fast, and probably no constituent is going to notice the difference here, but it creates a situation where our reliability more than doubles. So we've had 0 disruptions due to performance issues since we completed this work, and I'm going to knock on wood right now. All right. Talk about front-end performance, because I think that's another really interesting piece to this puzzle. The kind of mission statement that we had here is that constituents need fast access to information across many devices and varying network connections. So you need to provide access to, let's say, that press release that the governor just published, and people need to be able to access that on their mobile phone, on the subway, going through a tunnel. And in order to do that, you need to serve those pages very quickly, and you need to serve them very lean. They need to be small. Our hypothesis going into this actually was that Mass.gov is sort of the only place to get a lot of this information, and that constituents really probably didn't care that much about the speed of a page. They're not going to bounce because there's not really another place for them to go for it. But when we started digging into the numbers, we found the exact opposite. Our research was showing that if you saw a less than 1 second load time, you were 1.6% likely to bounce. And then that just scaled up as the time went on. So that was a very kind of good reminder for us that front-end performance matters even if you don't have direct competitors as a site. So the timeline here, we started addressing this stuff in April, and I think we finished up in May. First thing we did, we wanted to get that cheap and easy instant win out of the way right away. So we enabled HTTP 2. HTTP 2 is an addition to the HTTP protocol that allows you to like stream multiple static assets over the same pipeline and a couple other really nice features. We started seeing, like, this is a Google Analytics graph down here, and we started seeing some improvement from that, but it certainly wasn't the magic bullet that we were hoping for. Another really significant improvement that we made was we started looking at the responses that were being generated by some of the pages on the site, and we discovered that SVG was a huge chunk of it. So the HTML response is like the first thing that needs to be downloaded, and this HTML response was coming across the wire with, in some cases, up to a megabyte of data. So that whole thing had to be downloaded first, and then they could proceed onto like the static assets. That was a big deal, also because it was taking up space in our backend cache. I'll talk about that in just a moment. But we came up with a solution. Really, the issue here was that we had icons on the page, and anytime that icon was repeated, we were ending up with the exact same XML, SVG content embedded in the page. Like, it could be up to 100 times. So our solution was to implement a twig function. We made this twig function. This is kind of the before and after, and you can see that we had like an include statement for a twig file, and that twig file would contain this raw SVG data. And this raw SVG data would be embedded in each one of these little PDF links anytime we used them. So if you had 100 of those links on the page, it was embedded 100 times, and it might be, I don't know, like 20K or something like that. So that was crazy. And we switched to using this icon function, and we had some sugar there that said, like, embed the alert icon, and that knew that we went to look in this directory and for SVG dash whatever the name was, and then embed it. And the way we embedded it was using a use statement. So if you can see here, there's an SVG element, and then there's a use statement with an href that links to somewhere else in the current document. So we had all these SVGs embedded in a hidden div at the top of the page, and they were embedded one time per page, only the icons that were used. We pulled all this off using some really kind of black magic, but it works really well. So the effect here obviously is significant. This page was over a megabyte. It took over 30 seconds to load up in the browser, and that was because of the DOM size. After our changes, we had a 78K response. That's what we're seeing today. And the load time is 2.6 seconds. So for, this is obviously a microcosm. This page was one of our worst offenders, but really a significant change. And you can see that, like, we implemented that change here, and we didn't see immediate gains, but definitely it's part of the overall trend. The other thing on the back end is that the cache sizes that we were storing in the database went down tremendously. When we look at the render caching, that stuff ends up getting stored in both cache render and in the dynamic page cache. And if that one response is a megabyte, it's going to be stored twice. If we cut that down to 78K, and you think about that across like the breadth of our entire content, that's a really significant change. Huge effort went into cleaning up the JavaScript. We found an extra copy of Modernizer, one of Handlebars, a bunch of deprecated JS. I suspect that most sites have this kind of stuff, like baggage that they're dragging around that could just be cleaned up very easily. The other thing, we removed the Google Maps load script from every page and only added it on pages that we had a map. Seems like a simple thing. And then same with, I forget what CSE stands for, but it's Google Search. And we lazy loaded that so that Google Search autocomplete only loads when you click on the search box and start typing. And then it just loads in the file and shows you your autocomplete results. This was a big one. So we had those emergency alerts, and we were using JSON API to grab those from the back end. You can see the URL that we were using to grab them here, and this is a standard JSON API URL, nothing too custom about it. The size before was 781 kilobytes, and we realized that's huge. Why do we have so much data coming across the wire? We reformulated that URL to specify exactly the fields that we wanted to receive in that response. And we were able to cut it down from 781K to 16K for the exact same data. No change to how the consumer is actually seeing the emergency alerts. So really big win there. All that stuff is actually loaded asynchronously, so I think mostly what we were affecting in that case was the amount of time that it would take to show an alert, and also the bandwidth that we were consuming. And again, that emergency alerts response is going to happen for every single page view of the site, so that was a big one. We switched from WOFF web fonts to WOFF2 for any browsers that would support it. We also used what's called preloading. Just going to flip sides. Yeah, we used preloading to make those fonts requested immediately after the HTML response was received. This is an easy one to do. So there's a preload HTTP header that you can send back in your response that will say, hey, you know you're going to need these assets for this page, so go out and fetch these immediately. Don't wait for anything else. And normally the request chain for getting those fonts would look like you need to get your HTML, you need to find out what CSS is on the page. Once you know the CSS URLs, go fetch that CSS, parse the CSS, find any web font URLs you need, and then download those. So that was a pretty long chain to get those fonts back, and those are required for the initial render of the page. So we were able to shorten the amount of time it took for the first render of the page pretty significantly by just preloading those fonts. And I have a cool video that will demonstrate that in a moment. The other thing, WFF2 is about 25% smaller, and that matters because every browser is going to need to download those the first time it hits Mass.gov. I've already said the rest of that stuff. But yeah, you can see that we had a fairly substantial page load boost from that. Really simple change we made was switching from, in Drupal, there's a concept of an image toolkit, and there's an image magic toolkit available. It's a contrib module, and it has a toggle for optimize images. Just click it, and we saw some pretty substantial improvements here. Some of our big hero images were cut by 100K. And that's awesome because those images are not, those are content images. Those aren't something that we normally have the ability to affect as developers. Another really kind of major one that I didn't expect personally was we have this feedback form that I mentioned at the bottom of each page. This thing is coming from a third party, and it was embedded using JavaScript. So the page would load, then the JavaScript would go out and fetch the form stuff, put it on the page, and then as the user submitted it, the third party would handle submitting it. We took the HTML for this form, put it in static version on the page, and then wrote just a little bit of custom JavaScript to submit the form Ajaxy. And we saw really dramatic performance improvements as a result of that. So simple change, not hard to make, and big impact. Yeah, this one seems stupid simple, but our logo was costing us over 100K. We had this thing as one big image, and we chopped it up so that the seal on the left is one image that got reused between the header and the footer, and then the text to the right of it, which was actually in the web font that we were already using, is now live text rather than part of the image. And so by doing that optimization, we cut 100K and saw a nice little bump here. So the overall statistics that we were seeing after our front-end performance improvements were substantial, to say the least. This is one page, and this is one of our bigger offenders, but we cut the size of the page by 45%. And most of that was, well, it's coming from all different places, but the JavaScript was a huge difference. So like 300K after, 600K before. And a pretty significant portion of that was like our third-party JavaScript, the Google Maps API, that kind of stuff. Yeah, this is cool. So this is a visualization of the home page before and after. And I hope this works. So you can see on the right there that it just like immediately, oh, sorry, did I switch? Hold on, let me back up. Okay, cool. Yeah, so that's the home page. Before and after time was 2.5 seconds before, 2 seconds after, and you can see that like the web font loading is just almost instantaneous. On one of our guide pages, also pretty substantial improvements, and again, that web font change is just so visible when you do the side-by-side here. So the overall effect that we had was 35%. So we took it from an average of 3.6 seconds as reported by Google Analytics to 2.4 seconds. We were shooting for a 25% boost, and we got there. Okay, I guess we're at question time. Does anyone have questions? Yep.
What are you using for your hosting solution?
Yep. So we are using Acquia for the host. Yep.
You mentioned earlier about that SVG including the twig and function. I have to quote that just a little bit because that's
Sure. Yeah. So this was something that is fairly complex, but kind of behind the scenes on this thing, what's happening on the right here is that we are creating a render array that has property in it that, okay, so there's two components. We pop a render array in here that includes a custom element. Our custom element knows how to generate the use statement and bubble up to the top of the render stack the fact that we need to drop in that SVG embedded in the head of the page. So I understand that's a very complicated thing to parse. I'm happy to show you after what the code looks like. It's cool.
Yeah, I'm curious. It seems kind of like a neat way to.
Yeah, I thought it was a really elegant solution, and I think that it would be nice to eventually open source this. Just need to kind of clean it up and get it there.
You guys developed this, isn't it something that is available in Twig?
Yeah, this is in-house. Yep. Yep.
What's the main driver or tool to measure the performance, and how did you get to optimize this data and so on and so on?
Yeah, so that's a really good question. What were the tools that we used to measure performance, and how did we check in with that? So we had a couple of tools on the back end. We had obviously New Relic, which I was showing. We used Blackfire, which is a command line tool put out by Sensio Labs that will do profiling of individual pages. And those two tools, so we would use New Relic for how we were trending, and then Blackfire for we have a hypothesis, let's try it out and do before and after snapshots of an individual page. On the front end, we were using SpeedCurve to some degree, just to sort of keep an eye on our trends, and also just Chrome DevTools they have everything built into that.
If it's not a secret, what's the score of Lighthouse currently?
What's the score of Lighthouse? That's a good question. I don't know. I don't know.
Because they advise you a lot of things to optimize and
Yep.
basically for the life.
Yep. Yeah, I think it's hard to get a good Lighthouse score as a Drupal site, and I would guess that it's probably not fantastic. I know we've got some more improvements that we could be making on the front end performance front.
I can't remember what page it was that I checked, but it got an 89.
It got an 89?
Yeah.
Okay. So, yeah. I mean, it is going to vary page by page, too. So, yep. Yep.
Are you using a CSS framework?
That's a good question. I am not a front-end developer, so I'm probably the wrong person to ask that. I know that there is Bourbon Neat in our front-end tool set. That's a whole other topic. The front-end stuff is done in a really cool way using pattern library to do component design, and we have like a whole thing set up there, which I believe there are some presentations about on the web. But yeah, so that's to say that we are using like parts of Bourbon Neat, but I don't think we're using a general framework. Any other questions? Cool. Thank you all.